In whatever data ecosystem you find yourself in, be it data engineer or a data analyst, or even the machine learning engineer, you will be required to get data from various tables. Now, the clause that would actually help you get that done is called the join clause. The join clause is used to combine rows from two or more tables based on a related column between them. In this module, we are going to be looking at the various kind of joins like your inner join, your left join, and the right join. Now, let's look at the inner join. Now, the inner join will return selected records that have matching values on both tables. Looking at this Venn diagram here, where you have table A and table B, with a common column called column X, the inner join would return rows from column A that are matching with rows from column B based on a selected column called X that both exist in A and in B. Now, for clarity's sake, let's look at this particular table called the employees table. Now, this employees table have got an employee ID, the name of the employee, and the salary for the employee. Now, we then now have this table called the department table, where you have the department ID, the employee ID, and the department name. Now, what inner join or join would return would be records in the employee table that also exist in the department table, making use of a common field called the employee ID. Now, this employee ID can either be a primary key on any of the table or a foreign key on any of the table or both. Now, in this case, the employee ID is a primary key in the employees table, while the employee ID is a foreign key in the department table. Now, I can return matching data from both tables based on the employee ID. Now, what this table would return is it's going to match if employee ID in the employees table matches employee ID in the department table, and it would return 001, 002. It would also return 006 because these are the rows that are matching on both tables. The left join would return all records from the left table, which is table 1, and matching records from the right table, which is table 2. Now, if it doesn't see a matching record from the right table, which is table 2, it then now returns a null. Now, let's look at these two tables. I have my table 1, which is my left table for the student ID and the name, and I have my right table which contains students department. Now, the concept between the left join is it would only return all records from the left table and matching records from the right table. Now, if these tables have data that are not matching, it would return null. So if you look at the students table here, which is the left table, we have student ID 1, 2, 3, and 4 with student's name ABC. Now, taking this record to match data in the department table, we can see that in the department table, we don't have student ID 1001, hence the department will be returned as null. We do not have student ID 1002, hence the department will be returned as null. We also do not have student ID 1003, the department will be returned as null. But we have matching record for student 1004 on both tables, then it will return the corresponding department for that table, which is mathematics. So basically, left join will just return all the records from the left table and matching records from the right table. If we don't have matching records from the right table, in this case, it would be returned as null. Unlike your join, it does not even return non-matching records from both tables. The right join, on the other hand, is just the opposite of the left join. The right join will return all records from the right table, which in this case is our department table, and matching records from the left table, meaning that if we do not have matching records from the left table, null would then be returned in place of those non-matching rows. Now back to the example of our student table and our department table. What the right join would return would be all the records from the department table, which is 1004, 1005, 1006, 1007, and 1008. Now, for the student ID, we do not have corresponding names in the student table. Hence, 1005, 1006, 1007, 1008 would all return null as the student name. However, we do have their corresponding departments from the left table in our case here, which are mathematics, history, physics, and computer science. So it's just a little difference between the right join and the left join. Great. Now, how do you then now write joins from two tables? If you can understand these four steps, then writing a join would be very, very easy. The first step is to write all the columns you need for the join. Now, those columns are just, you know, basic specific columns that have been required either by your manager or whoever that wants you to write that particular query. So write out all the columns needed for the joins. The second thing is to specify the tables these columns are coming from. So when you have written down all the columns, you need to specify the columns that the tables are coming from. Say, for example, column A is coming from which table, column B is coming from which table, column C is coming from which table, and so on and so forth. Now, for each of the table you have specified, you need to qualify them with an alias, right? So the same way you have column aliasing is the same way you have table aliasing. So qualify each table using an alias. Now, this alias must be very, very short to avoid table ambiguity. Now, the next thing is to identify column or columns that are common to both tables. Remember our definition of joins from the introduction of this video. You join tables together based on columns that are common to both tables. Now, these columns can either be a primary key, a foreign key, or both. Now, one important document that is required of you to carry out a join is the ERD, otherwise known as the Entity Relationship Diagram. Now, this ERD contains a schematic diagram of all the tables in your databases and how these tables are related or, in quotes, joined together with their necessary primary keys, foreign keys, or with columns that are specific to one or more tables. Now, for this learning, I have attached the ERD for your Sales LT Schema database. Now, this is what the ERD looks like. You have all the tables in this database and the specific connections amongst or between these tables. Now, this relationship or these connections could be one-to-one, meaning that a table can only be related to one table and one table only, or it could be one-to-many, meaning that a table can have multiple relationship with 2, 3, 4, 5 tables. Now, based on our intuition on how to write your join using these four specific instructions. We will then now head over to our server and play out these instructions and see how we can write an SQL joins.